Yeah, I was just sitting here.
For sure.
Okay. There we go.
Yeah.
Very good. All right, I'll say it. Our dear Heavenly Father, we're grateful for this week that we've been having, that we can have this time to meet together as a math group. Please help us to be able to discuss and learn from one another, and that we can be inspired with any problems that we might encounter with our problems. And we ask for these things and say these things in the name of Jesus Christ. Amen.
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 Okay.
So you got to be good. Sorry, my son wants to watch, so.
Awesome.
Okay. Instructions for Google Hangout 2. Begin by discussing any questions your team members had in preparation for the exam. If you are unable to answer a question, be sure to send that question to your teaching assistant and/or instructor.
I mean, I felt pretty confident with it. My only thing, like I was saying a little earlier, is I just got to keep straight the rules, and because that's one thing I was having a trouble with, was just not using the right, I guess, order of operations.
Mm-hmm.
But
yeah.
Yeah, I mean, I did find out if it's like a log minus a log plus a log, you can't. I was like adding the last two logs together and then trying to do the subtraction division thing, and no, you're supposed to do it one log at a time. So that helped.
Yeah. Yeah, there are just so many different rules, like that could. Yeah, I don't know. There's just a lot of rules.
Yeah. I'm gonna try to pull up the book so that I can reference it as we're going.
Okay. Yeah. Yeah, I don't think I have any specific questions.
Okay. Okay, so let's see. Do you have any questions?
I don't know.
All right. Were you all able to do the extension problems? Or like a few of them, or I don't know. Could talk about a couple of them maybe before I go on to the quiz.
I actually didn't go through the extension problems. I kind of forgot about them.
Okay. Yeah, no problem.
I didn't either. I looked at them as all though.
You have to eat so loud. Don't want it. I don't want it. I mean, do y'all want to work through a couple of these problems, or is there anything you have a question with? Because, excuse me, we could work on it here and then check out the key. Or if y'all just wanted to spend the time tracking down on the quiz, I don't know how much time you've got.
Yeah, I have 45 minutes to be done by 8.
I'm about the same.
Okay, yeah, I'm the same. My husband's class meets right after this, so.
Okay.
Okay.
Should we go ahead and start on the? I mean, how about take a look at the extension problems and see if there's like one that you want to work through.
Okay.
And so we can work through that. But if not, then we should probably just start on the quiz.
Okay. I'm going to see if any of them are similar to the quiz to try and see how to work them out.
Uh-huh. Yeah, I spent 3 hours at the math lab today working through the extension problems.
Oh,
Golly.
dang. Wow.
So one thing I hate about living in Idaho Falls, I can't really just go out to Rexburg that often.
Yeah.
Making a little trip.
Yes.
I should take a picture of that.
Yeah, I guess one, I haven't gone over too much yet. I've just been going through my math lab stuff for the most part. Is the ones with exponents.
Yeah, the graphs.
Yeah, so I think the second to last are -3(2) to the power of x plus 1. Honestly, I have no clue what to do with that kind yet.
Okay, let me look at my...
You said that was number 1?
It's the 1, 2, 3, 4th extension problems.
Oh, okay. Pretty good pieces. Let me see.
Do you want me to explain how the people at the math lab told me how to do it?
Sure.
Okay, so basically, so it's the -3 times 2 to the x plus 1 plus 4 minus or equals -18, right?
Yeah.
So you start by taking or subtracting 4 by both sides, so the 4 is out of the left side. And then divide the -22 by -3. So you get positive 22 over 3. And then after that, you can take, what happened there? Let me look at you can take the, here it is. So you take the log to the base 2 of both sides, which then for the left side, that cancels out the 2. And so you bring the exponent down. So it's x plus 1 equals log base 2, 22 over 3. And then, let's see. Ignore this side. This is where I messed up. And then this is where, so here, I took the log to the base 2. That canceled the 2 out. And so you're left with x plus 1. Log base 2, 22 over 3. And then you simply just subtract this side by 1. So you're left with x.
How'd you get the log 2 to go away?
Log base 2 on both sides.
Yeah, so the log base 2 up here, I had kind of wrote it out kind of weird, but let me try and make it a little more clear.
Yeah, I
sorry,
saw that somewhere.
A little fuzzy.
Yeah.
So, yeah.
I don't want it.
So, wait one sec.
Cheeto. Do you want to go give it to Daddy? Give it to Daddy.
So we have, so here's the, wait, okay, one more second. I'm confusing myself. 2, okay, and then x plus 1 log base 2 to so right here, so you have 2 to the x plus 1 power equals 22 over 3. And then if you take the log base 2 of both sides, that essentially right here just cancels the 2 on this side of the equation, and you can bring the x plus 1 down.
Could you possibly hold the paper a little close? It's all blurry, like I can't see a thing.
Oh, yeah, I'm sorry.
That's good.
Oh, there we go.
So log base 2 cancels that 2 out, and you're left with the x plus 1. That just comes down. And then over here you have log base 2 to the 22 over 3. And then you simply just subtract by 1 on both sides, and you're left with x. So log base 2, 22 over 3 minus 1. Does that make sense?
Yeah, I wasn't, whenever you did log base 2 on both sides, instead of doing log base 2 of 2 to the x minus 1, I was just putting log base 2 of x minus 1. So I was leaving out that 2.
Okay. Yeah, essentially.
Hey, I don't want you to go back.
Brought down. Yeah, the x plus 1 is just brought down after that cancels out.
Okay. Yeah, the exponents are definitely a tricky part for me.
Yeah, same.
Can you get me a white piece of Cheeto? Don't touch my calculator. You need to wash your hands.
So would that same principle apply to the next one as well?
Wash your hands.
2x equals 3x minus 1.
Let's take a look.
Well, because you're only going to be able to cancel out one or the other sides, right? On the next one.
Yeah, that's what I was wondering.
So for the next one,
well, couldn't you just do like the log of base 2 for the next one, so that it would just give you an x equal? Well, never mind. Then you'd still have an x.
You're gonna actually use the natural log, so the ln. Let me see if where's my other. I know I have another piece of paper here. Log. I guess I just have this picture. Okay, or paper. So here, I know I have another piece of paper somewhere. But this is what how am I gonna explain this? Okay, so what we have going on here is we have, so the x, or 2 to the x equals 3 to the x minus 1. So you take the natural log of both of those problems, which just, then you're left with x ln 2 to the is equal to x minus 1 ln 3. And then you just go ahead and you multiply the ln 3 by first the x and then the negative, or the 1, or the negative 1. So you're essentially just factoring those two out. and you get x ln 3. Ignore this part, this comes later. Minus ln 3 equal or minus x
ln 2.
Oh, yeah. So this is actually, I was trying to find the piece of paper with my work on it. This is the one that one of the guys gave me. But basically, yeah, after this is the part I got stuck at. And so after this, I was able to kind of figure it out. But you basically just like move all the terms with an x in them to one side of the equation. You got an x ln 3 over here, and so basically he added the ln 3, which doesn't have an x in it, over to this side, and subtracted this side, subtracted the x ln 2 from this side, and so that got over here. So that's what this is happening. That's what this is right here, and all this weird stuff, and then is left with ln 3 is equal to x ln 3 minus x ln 2, and then you just factor out an x, so you're left with x. Okay, that's just showing that he's dividing that. But x ln 3 minus ln 2 is equal to ln 3, and then divide both sides by ln 3 minus ln 2. So you're left with x is equal to ln 3 divided by ln 3 minus ln 2. Does that make sense?
Yeah.
Okay.
So yeah, I was just saying the formula for that is just, I think I got it. Just moving those exponents down.
Mm-hmm. Yeah, I got pretty stuck on that one too.
Yeah, sometimes I got to remember. I don't know why. I know log and natural log are different, but sometimes I try to just do the same thing in my head, and when it doesn't work out, I'm like, oh yeah.
Yeah.
Do we have any? Let me double check. Any natural logs? Well,
I don't think so. On the quiz.
yeah, I think it's mostly rule of logs, and then the property. We might have to use it for something, but yeah, it's not asking us anything for it. But still good to know.
Is number 2 natural log?
Oh yeah, see, to solve it, I think.
Oh, wait a minute. Maybe it's just no. I think it's just because it's in terms of log b.
Mm-hmm.
So I think it's just that. I don't even know if we have to. We might have to use it on question number 3.
Right.
Yeah, I don't know.
Yeah.
We want to get started on the quiz.
Sure.
Okay, yeah, it's already like 7:30.
Yeah. So if log A 3 equals $, and log A5 equals £, rewrite the following expressions in terms of $signs and £signs. Interesting.
So this one it would be log A $, plus log A £. Since you can multiply it'd be like 3 times 5, kind of.
Oh, that makes sense.
Yeah, because when you add, you multiply, right?
Yeah.
Yep.
And subtract is divide.
So log A third or to 3
$sign.
log A 5, which is then, because it says to write in terms of $signs and £signs.
Yeah, so log A $, plus log A £.
Oh, okay, that makes sense.
Yeah, so just put them in parentheses after the log.
Okay.
Each one.
Or we could always just put the 3 and the 5 and then erase them and rewrite them later.
Yeah,
If it
pretty much. And then
Okay.
Yeah, so B is 3 divided by 5, but that's the answer.
so that's $, over £. Sign.
So then it'd be
Over pound.
Yeah.
so it'd be log
Log
A
Log A
$sign minus log A £sign.
Yeah.
Is that what
Yeah.
I'm understanding?
Yeah, I think so, because then that would lead to
Yeah. The top number
I'm
goes
assuming-
first.
Yeah.
Yeah.
Okay.
Because then it would all simplify out to 0.6, which you know.
Mm-hmm.
So C is
That'd be 5 to the 3rd power.
oh, I see.
So then it's $sign log
A
£sign.
of £sign.
So that's kind of like what you just went over, right?
Do you have to take the natural log or anything to get that $sign to the £sign, or does it just can you automatically take it and put it at the front if it's
So this is what I put. I don't know if it's right or not, but the log A of 125 is $sign to the log A that, because if this is 3, there's that one rule, I forget what but it's like basically this is the exponent of this just moved over here. Like, do you remember that rule?
Yeah, okay. I just wanted to make sure.
I'm not sure if I'm right. I'm just
Yeah, I'm pretty sure. 'Cause, yeah, if it's an exponent, you bring it out to the front like a coefficient. So
okay.
yeah, I'm pretty sure that'd be right.
Okay.
Let's see.
So then
So wait, so what did you say that one was? Just so I can have it written down as well.
yeah, 1 second.
Was that one dollar or yeah, it was
So it's $sign log A £sign.
$, log A £. Okay.
Yeah.
Cool.
I'm not sure about this next one though.
yeah, because we're gonna have to be using different like numbers, right?
Would it be because 27 divide, wait, let me think about this before I, would it be $9 over 5 £?
Yeah, see, that's what I'm thinking. Can't we just like do the subtraction, but just multiply, the $ with another number and the £sign with another number? Because I mean, it would be right.
That's the only logical explanation I can come up with.
So it'd be log A $ times, is that 9? Minus log A £. Oh, wait. Oops, hold on. Oh, wait, no, it would be log A $ to the $ minus log A £sign to the £sign.
Well, because £, I see how $ would work, but £, would have to be.
Or sorry, oh wait.
Yeah, it'd be so wait a minute. Yeah, never mind.
Okay, well, I was on to something there. Yeah, so the $ could work. Yeah, $ to the $, but the £sign would have to be £sign squared. Does that work? I mean, mathematically it would come out, but
I think.
Or I mean, you could do log A $ to the $ minus log A £sign times £sign. Because I mean, that would give you the 27 and the 25, but I don't know if there's any specific way she's wanting it. Though in a lot of these problems, I mean, she does say there's like, 4 ways to solve it. So I don't know if that'd work.
Let me think about this. If it's
Yeah, y'all want to just move on to the next one? Maybe come back to that.
Sure. So the next one, log a to the, or log a square root of 45.
So this one's gonna be like that. If it's the square root, hey, can I have my, then it'd be like 45 to the, let me see, sorry, my tab just closed. 45 raised to the power of pound something. I just closed my quiz.
Would it be to the power of 1/2?
Yeah, isn't it 1/? Yeah, I think it's 1/2 when it's the square root. So would you even need pound or anything there? Well, to get 45, because then you would have 1/2 log of a of 45, but maybe they want us to simplify 45.
Could we add in like say $sign was like X or something? 45 would be would be $15 sign. I'm not. That's just an idea I'm throwing out. I'm not sure.
Yeah, so what you're saying is like it would end up 1/2 log a of $15 sign.
Or because it says to use. It says put in terms of $signs and pound signs. Does that mean we have to include both?
So would it be like 50, or would it be like 15 times 3 to the power of 3?
Yeah. Or why don't we do
those?
Yeah, if we just had to use those, we could do 1/2 log a of $sign, pound sign, because that's 3 times 3 times 5, which equals 45.
Okay.
If it was in simplest form, as long as she's not taking that to be like 335. Just put the little dots in between so that they're multiplying.
So 3 times, so $sign. Here, I'll put it. But then, so $sign doesn't equal 3. $sign equals log a of 3.
Oh, you're right. I didn't even.
Yeah, I don't know.
I didn't even catch that. You're right. Oh, okay. Oh. Huh.
Well, so these previous 3, like the first 3 were like pretty straightforward, following the rules of the logarithmic, like the logarithmic rules. So I'm wondering if these last 2 have to do with like a specific correlation of one of these rules. I'm pretty sure D, the question that we are struggling with before, is going to be log a $9. Wait a minute. Log a $9 sign. Then that just brings back.
Yeah, now it kind of changes things. I should have looked at. Can we use any of the rules to cancel it out, I wonder?
Use the what?
Like how it's log of A of 3. Hold on. Yeah, log of A of 3. But if you raise 3 to the A, it's never mind. That doesn't work. I'm looking through the rules and trying to see if any of them will come out to something. Wait a minute. Here, I think I might have something with D. Give me a second.
Well, you got my jacked up.
Okay, yeah, I think I got this one. Okay, so for D, so I don't know if you can see. Let me try to hold it up if my computer will do it. But so that's the normal one, the log of 27 over 25. So in order to get them over, I subtracted them, and then 3 to the 3 gets you the 27, and then 5 to the 2 gets you that, and then I used the power rule and put the 3 in front. So 3 log A of 3 minus 2 log A of 5, which would be, I guess,
so it'd be
$3 sign minus £2 sign.
That makes the most sense to me, I guess.
So let me write the last little bit. So that's 3 log of 3 is dollar sign minus 2 log A of 5, which is pound sign. Yeah. So I think that's what it is.
Yeah, I mean, sounds good to me.
Now E is still a question.
Could you even break that up further? Because if you did log A 5 times 5, you could break it up into 3 log A 3 minus log A 5 plus log A 5.
Say 3 log A3 plus 5 log A5.
Yeah, so hold on, let me see if I can
Well, in order to get the square root, all we have to do is times it by a half, right?
Times it by the power of a half. Yeah. I think.
Okay. So I mean, if we could just simplify that down to log A of 3 and log A of 5, and then have it multiplied by the half, I mean, I think it would check out.
I was saying something kind of like, where's my camera? Like that. If you have to have it all pounds and dollar signs.
Okay.
Okay.
Would that work, maybe? I don't know. Because then it takes part of what she did with the 3 log A3, and then you're still simplifying that 25 all the way down to where you can use the symbols in there and not have the 2 in there.
But see, in that one, we would still have to use the number 3 at the beginning. But in that instance, the 3 log A of 3 minus log A of 5, that would instantly put 3 over 5.
Yeah, it all just turn into what? Dollar sign log A dollar sign minus log A pound plus log A pound.
Well, no, the dollar sign is log A of 3, so it would be $3.
Yeah.
Oh,
yeah. Dollar sign isn't 3.
No, never mind.
Makes sense, though.
Unless you did the exact same thing, because it's 3 to the power of 3. So you could just make it log A 3 times 3, and then simplify it out to log, what was I looking at? Log A dollar sign plus log A dollar sign minus log A pound plus log A pound. To kind of do the same thing I did with the 5s, but make it into the 3s. Never mind, because you'd have to do it 3 times 3 times 3.
Yeah.
Wait, no. Yeah, that would work, I guess. No, never mind, never mind.
Yeah, these are just tricky. Yeah. Yeah, because since it doesn't say we can't use like other numbers, I mean, I'm pretty sure it'd work if we did. You know, if we had to add in like a 2 or a 3 or whatever other number we needed. Because it doesn't say just use. It just says in terms of them. Yeah, my best guess is $3 sign minus 2 pound.
Yeah, but we'll stick with that.
Yeah, it's the shortest and simplest answer.
Yeah.
Oh wait, that one was D. Okay. But with E, kind of what y'all were saying, couldn't we just do like, does it work to do just, no, that doesn't work, never mind. Because you can't just times dollar sign because it's not 3, it's log of 3. Log A of 3. The textbook doesn't give a lot of help to the square root problems.
I think it's
Yeah, I agree.
I think it's just like 2 to the power of 1/2.
Yeah, my only question is how we get the 45.
Oh yeah.
Because I mean, I don't know if it's just, maybe I need to look at the rules again. Because I know we can't just multiply the log of, log A of 3 and log A of 5, because that's not exactly, that's not just 3 and 5. Excuse me.
Hmm.
Oh, wait. Well, what if we just did 1/2 here? Would this work? Because if it's log of A of 3 plus A of because when you add them together, the insides get multiplied, right? So wouldn't you just have to add them all together and coefficient of 1/2 or whatever to get the square root? Would that equal
Oh,
would that equal it?
log A3 log A5 plus log A3 dollar
Because when you
sign plus
yeah.
pound sign plus dollar sign to the
Oh yeah, I wrote them in a funky order.
no, it's fine. So then it wouldn't just be $2 sign plus pound sign? Can we do that?
Does
Yes. I mean, you
Does
can
that
write
work?
this step out, and then if we wanted to simplify it
Yeah.
and combine 2 of those terms, then we could. That way we just have both of those in there, kind of.
Yeah, because does 2 log A of 3 equal the same thing as log A of 3 plus log A of 3?
Say that again?
If we were to put like a 2, like 2 log A of 3, since there's 2 of them, does that equal the same thing, putting the 2 as a coefficient, as it would writing them separate?
Oh,
I just want to make sure there's no funky rule I'm forgetting or something.
yeah. I think so.
It's this. So you're asking like log 3 plus log 3 is the same as 2 log 3?
Yes.
Yeah, they'd be the same.
Yeah.
Okay. Phew. Excuse me.
That's good.
Oh, well, that's good to know.
Yeah, that is.
So then log A3 plus log A5 plus log A3, which is then just $2 sign times pound sign or plus pound sign.
Yeah, see, we're getting it. It's not bad.
Okay. I guess on to the next one then.
Come on, after doing like those 5, this one should be easy, right?
Hopefully.
So I guess that, I mean, that one can be broken up into chunks, or I don't know if y'all want to, us each
Yeah,
try to do it.
I'm starting to work on the last one, I think. Let me go back and look at it. Yeah, I'm working on number 4 right now.
Oh, sorry. No, that last one, I wanted to know whenever we get there, what y'all got, because I did that one, but I don't know if I did it right.
Number 2.
No, I was talking about number 4, but we're not there yet.
Oh, okay.
Yeah, I'm just working on it as we. I have no clue how to do number 2, like exponents and square
I'm
root.
working on 2 right now.
Okay. Yeah, let's see. That times that. So then that would be. To the 5th.
To expand. Okay. Okay, so I think I got number 2 now.
Okay. Yeah. Like I worked it out. I know it says like do it and like simplify it, but I didn't really understand how to simplify it. What'd you get for it?
It just says to expand it. Oh, and simplify. Oh. I wouldn't. Well, so what I got was this long thing right here. Oh, 1 sec. So I got 1/4 log b plus, I think that, what is that?
5 log bx.
Yeah, 5 log bx
Oh.
Plus 6 log b
yeah.
minus
7 log by.
And then 16 log bz. I don't know if that can be simplified, honestly. I think the simplified form was this, is what.
Yeah.
Yeah. Would everything excuse me, would everything have to be like in parentheses for the 1/4? Or does it just automatically make it all the square 4 root thing?
You mean like put a parenthesis here and then all the way down here?
Yeah, like all the way at the end. Would that have to happen? Oh no, never mind.
I don't think so.
Yeah, I don't think so either. I just thought it in my head because then that would all multiply it by a 4th. And yeah, no, I think what you have it is right. Now, see, I think when it meant simplify, like I think we did it right because originally I kept like x to the 5, but I forgot you can pull the 5 out in front, and I think that's simplifying it. So I think we're good.
Okay, that makes sense.
Yeah. Sorry. Okay, interest.
At what interest rate compounded annually would this growth occur?
I'm gonna run to that section of the textbook because,
For number 3?
yeah, just to make sure. I always put the wrong thing in the wrong spot here. It says we can use a textbook, so I'm gonna use it. Yep, I think I found the equation for it. Come on.
Oh man.
So 2,200,000.
Wait a minute.
Yeah, don't we have to use the natural log for this?
Yeah. Take the natural log. It just brings 200 down.
I got 3.1% as the rate. Not sure if I did natural log right.
Oh, wait a minute. I don't. Oh, wait. One more second. I'm not sure we actually do have to use the natural log for this. I was looking at an example problem.
Hey, Giovanni, cut that out. Yeah. Yeah, I found in the textbook where it talks about finding the rate.
Uh-huh.
And it's like, excuse me, sorry, my voice is going out. And it uses the y equals AERT to find the rate. And then it's like, if we know the values of the other variables, we can find the rate by solving for r using natural logs. So if y equals ABT.
So this one, I think, if I remember correctly, is going to be the A equals P1 plus Rn to the NT because it has the word annually right here. And so that means that there's an n value, and which is just 1.
Oh, I see what you mean.
And then for the other equation, if it has the word continuously in the problem, then we would use the other problem, or the A P E R T one.
Okay, I see what you mean.
Yeah. And so for what did you say you got for this one?
I ended up with 3.1%, but yeah, I don't think I was working it the right way.
I got 3.2%.
Did you round up?
Here, so let me show you what I did.
We got to be in the right ballpark, right?
Yeah, pretty much. Well, so here, so when you get to here, what I did is I took.
Could you hold it a little closer? Sorry.
1 over 200, both sides, which just canceled the 200 exponent over here, and brought it over to the 500. So it's 500 to the 1 over 200.
Okay. Yeah. See, honestly, I would go with that because I did the same thing, except I didn't do the 1 in it because I did the continuous model, not the. I didn't see the periodically, so I wouldn't doubt if that was it because I mean.
Yeah, I don't know. And then, and so I plugged that into the calculator and then subtracted it by 1, and I got 3.2%.
Okay. Here, let me see something. If I. Yeah, I mean, I'd be willing to go with that. I mean, the math looks right. My math was just wrong.
Right. So what about number 4?
Okay. So for number 4, like just so using like would it be like, could you simplify the log of x minus log of x minus 1? Could you simplify that into the log of minus 1? But I mean that doesn't equal 2, so that was my only issue with number 4.
So here's what I've done so far. No problem. Yeah, so
Okay.
Oh.
Yep.
There you go.
That makes sense. Because there's no base. So it's just log base 10.
This is why I like having all these minds here working.
Yeah.
Definitely helps.
Okay.
So then,
And I don't know if I haven't simplified it farther than that. If you can, I don't know.
equals x, 99x equals 100. So I got 100 over 99. Does that make any sense?
Here. Let me see. What did you get?
So I have this down here. 10 squared to the x, or times x minus 1 equals x. I just factored that out. 100x minus 100 equals x. Subtract by an x. And then add the 100 on this side. And then divide.
Yeah, I mean, that's what I got as well.
Okay.
Yeah, let me see. I don't know if I subtracted wrong. Yeah, I have the 100x minus 100 equals x. And then did you subtract the 100x? Is that what you brought?
No, just the x.
Oh.
So move this x to the side, basically.
Yeah, the way I did it was like that. I don't know if that's correct.
Which
math.
also makes sense, yeah.
Yeah,
100x minus,
Sorry,
yeah,
I'm get the same answer.
Yeah.
So to get the 99x, you subtracted the 100x, right?
Yeah, so it gave me negative 99x, and then I divided the negative 100, or the negative two negatives to give me the positive.
Yeah.
But wouldn't that be one minus a negative 100? So wouldn't that add it together? No, sorry. Why am I thinking of double? Okay.
Yeah, because you're dividing.
Yeah, I don't know why I was trying to minus a minus.
Okay.
Okay, there we go. Yeah, now I get the 99x. Thank you.
Yeah.
Yeah, 99x over 100. Yeah, I'm over here with like negative 0.99 and it's not making any sense at all.
Go get your diaper.
All right.
So is there any other questions or any other else that, did we skip over anything or?
No.
I don't believe so.
I think we got it all.
So are you good with submitting it, Josh? You're the one who submits it, or?
I don't care. I can submit it if you want.
Yeah, sorry. I don't know how to get it to a PDF now, and I don't know if she's real picky about that or not, but I don't know.
Yeah, what I do is I downloaded a scanning app on my phone, and you just take a picture of it, and it converts it to a PDF.
That's what I did.
Yeah. Is that just the Adobe app, or what is that? Because I've heard of that, but
I just use. Let me pull it up on my phone and see. think it's called like Fast Scanner or something.
No pooping.
Because I feel bad making everybody else just upload, but I don't want to have to. Hey, leave that alone.
I might actually delete it off my phone.
Well, I might tinker around with some apps, see if I can find something, because I've heard there was an app that could do that, but
Yeah, here we go. So here's the one I use. Without the glare on there. Don't know.
fast. Sorry, fast scanner, free PDF scan. Okay.
And then it just lets you like save or download the file to your phone, or you can like email it to yourself, or however you want. But I've used it for a couple years and I've liked it.
Okay, cool. Thanks. I gotta go to the library to download it because our Wi-Fi is terrible. Hey, leave him alone. Leave Daddy alone.
Yeah, I don't care who sends it in. I can send it in if you want. Or it doesn't
Okay, I'll
matter.
go ahead and get the video uploaded, and maybe next week we can switch it around so no one
Okay,
gets burned out.
sounds great.
Awesome.
Thank
Well, thanks.
y'all.
You guys have a good one.
Yeah, you too.
You too.